Today's lesson is 10.3, Surface Area and Volume of Spheres. A sphere is a set of all points in space that are the same given distance from a given point, which is called the center. Here is the center of my sphere. A radius is a segment from that center to a point on the sphere. A chord of a sphere is a segment whose endpoints are on the sphere, and the diameter is a chord that contains the center. Here's a better picture so that you can see the diameter and the radius. And then this circle here, that if you can imagine, that kind of makes the circle into the sphere, makes it into a ball, a 3D shape. That is called a great circle. All right. There is only one surface area formula, and that is the total surface area formula, because we cannot take a sphere and break it down into a net like we can a pyramid, a cone, a prism, or a cylinder. So TA for my total surface area is equal to 4 pi r squared. Let's go ahead and get started. Find the total surface area of a sphere with radius 3/2 centimeters, 3/2 centimeters. All I have to do is plug this straight into the formula. So I'm going to copy down the formula. My radius is right here, and it's going to be the 3/2 centimeters. So I'm just going to go ahead and plug it in. And I'm going to go ahead and square it. Now there's a couple of different ways that you could be asked to do this problem. Let's see if I have my Desmos. I do. You could be asked to leave this in terms of pi. Let me go ahead and clear all of this, which means you would just be multiplying 4 times the fraction 3/2, oops, hold on, squared, which is 9. And leaving it in terms of pi. So we could say that it is that, or you could be asked to multiply it all together. So 4 times 3.14 times the fraction squared. You could be asked to do the whole thing. It just depends. Go ahead and make sure that you read your question when you get to your ALEX, because the top one, the 9 pi, is in terms of pi, and it'll say that. And the second one, the bottom one, is when it says use 3.14 for pi. Okay, I'm going to go ahead and clear that and slide that over a little bit more. And let's take a look at the next one. Find the radius of a sphere with a surface area of 24 pi meters squared. All right, so I'm going to take my formula. And they're asking me this time to find the radius. Find the radius, it says. I'm going to go ahead and make the radius the color purple. That means the 24 pi is going to go over here on this side, and I have this on this side. I'm going to put the radius in purple. Now, what I can do is I can think of this as a number being multiplied by the radius. So I'm going to go ahead and divide both sides by 4 pi. This way the pi's cancel out on both sides, and I just have 24 divided by 4, which is 6. But my radius is squared, so I'm going to have to take that 6 and I'm going to have to take the square root of it, because that's going to get rid of the square and it's going to give me my final answer. Now, you could leave this as the square root of 6. More than likely, you'd be asked to round the 2.4494. That's probably more than enough that it's going to ask you to round. Let's say 2.45 centimeters. Okay, I'm going to slide the Desmos right on off the screen. Let's go ahead and talk about the volume of a sphere. The formula for the volume of a sphere is V for volume equals 4/3 times pi times the radius cubed. So all you need to know for the sphere is the radius, and then of course you have to recognize pi and then recognize that you could be asked to use 3.14 for pi. All right, so it says find the volume of a sphere with a radius of 2 centimeters. So I'm just going to go ahead and underline that. Let me zoom in a bit. I always like to start with my formula. I find that if I copy down my formula, I tend to not miss stuff. Sometimes when I don't copy down my formula, I miss things. All right, so once again, you could be asked to leave pi, leave in terms of pi, or you could be asked to use it as 3.14. So let me go ahead and show you that. I'm going to go ahead and clear all of that. I would put 4/3 in first. Oops, I want to go to the bottom. There we go. And then I would multiply that times 2 to the third power. Now notice it is giving me a decimal, so I'm going to go ahead and change that to a fraction. And I could think of this as 32/3 pi. And what was the unit? Centimeters cubed. Or I could take that fraction, 32/3, and I could multiply it by the 3.14. Now in this case, you would probably leave it as a decimal. So 4/9, and then it looks like it's 3 repeating centimeters cubed. In that case, Alex is probably going to ask you to round to a certain place, maybe 33.5 or 33.49. All right, I'm going to slide that over for the last question. Find the radius of a sphere with volume is 288 pi centimeters cubes. Always start with your formula in a problem like this. And they want us once again to find the radius. So I'm making that R purple. I'm going to put the 288 pi over here. And then I'm going to think about it as 4/3 times pi times my radius cubed. Okay, there's times in here. Now this one I'm going to do a little bit differently because of the fraction 4/3. I'm going to go ahead and divide both sides by pi first. It's going to eliminate my pi on both sides. And now I can deal with the fraction. To get rid of a fraction, the quickest thing to do is to multiply by its reciprocal. So I'm just going to take that fraction and I'm going to flip it. 3/4, and that will cancel this out. What I do to one side, I must do to the other. So what I'm going to do in my calculator is I'm going to do the fraction 3/4, and I'm going to multiply that by 288. I get 216 is equal to the radius cubed. To find the radius, I am going to take the root, but this time the cubic root. So I got to make sure that my root has a little 3 in it. I'm going to pick the root. Let me show you where it is. It is right here in this row, but it's the second one. It's the one that looks like this with the letter N in the middle. That allows me to change the root to 3, and then I can put 216 inside, and my radius is 6. I'll put it over here.